Hello guys, this is for CS520, presentation 3, topic 3, proof by induction. My name is Jiang. Here's my email address. So here we are looking at the problem statement. So in this equation, the left hand side is the sum of k cubed from k equals 1 to n. The right hand side we have n squared times n plus 1 parentheses square over 4. And we're going to do an example. Let's set n equals to 5. So the left hand side will becomes k equals to 1 to 5. And k cube, that means you have to plug in 1, 2, 3, 4, 5 into k cube and sum these numbers up. And the right hand side, you just simply plug in 5. So after do the math, you get 225 on both sides. So talking about mathematical induction, we can think about the case of dominoes. S1 is the first domino going to fall, and it's going to hit S2 and keep hitting the next domino. And for some integer k, so the sk will implies the sk plus 1. So this is the goal for the presentation. We're going to use 4 steps to prove the relationship between these two dominoes. So we're going to state a base case, then prove the base case is true. Then we're going to establish the inductive hypothesis, and we are going to prove the inductive case. So for the base case, we're going to set n equals to 1. So when n equals to 1, we are going to have 1 cube on the left hand side, and then we have 1 square times 1 plus 1, which is 2 square, over 4, which is also 1. So the left equals to the right. That means the base case is true. So we're going to establish the inductive hypothesis by assuming sk is true with value k must greater or equals to 1. With that, we're going to prove this statement is true, that s of k implies to s k plus 1. So to do that, we're going to first express s of k into this equation by substitute k into n from the problem statement. And instead of using k here, we're using I equals to 1 from I equals to 1 to k of I cube. And we'll do the same for s of k plus 1. So this statement becomes s of plus k parentheses square, because since you are plugging in s plus 1 into the variables here. So here we have k plus 1 plus 1, which is k plus 2. So we have two we have the expressions for two statements here. So here we are at the last step, which is to prove the inductive case. The goal is to prove s of k plus 1 is equals to s of k plus k plus 1 to the third power. So by substitute the expression from previous slide, so we have this long equation. So the left hand side is s of k plus 1, the right hand side is s of k and plus k plus 1 to the third power. So now we're going to divide this equation. So the first term on the right, it's actually s of k. So we replace the expression like this, and then so on this term, the second term, we're going to multiply 4 over 4. So we are going to have the common denominator. And because of that, we can combine the top term together. I mean, adding the two terms. And then because they both have the k plus 1 square, so we're going to factor that out. So so the first term here will only remain a k square, and the second term here we still have a k of 4 times k plus 1, which is like this. And then we're going to multiply the 4k plus 1 out. We got k squared plus 4k plus 4. So we can simplify this this term here using algebra. And then we got k plus 1 squared times k plus 2 square over 4, which is the same as s of k plus 1. So that means this is true. So we successfully proved the statement that we established from step 3. So that's the end of the presentation, and here's the reference I use in this for the content. And thank you very much.